In this lesson, we will look at a helpful tip regarding the order in which you should examine the two statements in a data sufficiency question. Now, when tackling any data sufficiency question, it is important to remember that you are not required to examine the two statements in any particular order. So you can begin with either statement 1 or statement 2. Now, which statement should you begin with? Well, to answer this question, we should recognize that when the test makers develop a data sufficiency question, they can make the question harder to solve by using two techniques. Both of these techniques rely on the fact that most students examine the two statements in the order in which they are listed. That is, they examine statement 1 and then they examine statement 2. With this in mind, test makers can make a data sufficiency question harder by making statement 1 more difficult than statement 2. So if a student examines statement 1 first, and it is more difficult than statement 2, then the student may have problems determining whether or not statement 1 is sufficient. As such, he or she may become flustered and be unable to solve the question altogether, or waste considerable time. The second way that test makers can take advantage of the fact that students typically examine statement 1 first is to write statement 1 in such a way that it causes some students to accidentally carry information from statement 1 over to statement 2, and thus cause these students to answer the question incorrectly. Now, given the two techniques for making data sufficiency questions more difficult, we might conclude that we should always begin by examining statement 2 first. This is not the case. When tackling any data sufficiency question, we should read both statements and then decide which one to examine first. The statement that we choose to examine first should be the one we feel will be easier to determine the sufficiency of. Let's look at an example. In this question, we want to find the value of 5x squared plus 1. So to answer the target question, we need to find the value of x. Now notice that each of the two statements provides an equation involving x. Of these two equations, the second equation appears to be the easiest to solve. Of course, this should come as no surprise since I created this question to illustrate a particular point. Okay, let's take a look at statement 2. Now, as mentioned in an earlier lesson, we always want to avoid overcalculating. For statement 2, we should be able to recognize that we could solve this equation, and doing so would yield only one value for x. Since statement 2 will yield only one value for x, the expression in the target question will evaluate to be only one value. As such, statement 2 must be sufficient. Now, since statement 2 is sufficient, we already know that the correct answer will be either B or D. So if we were unable to determine whether or not statement 1 is sufficient, we would have only two possible choices to guess from. Now, just for fun, let's tackle statement 1. This equation is already set to equal 0, so we may be able to solve it by using some factoring techniques. In fact, we're going to factor the left-hand side in parts. First, we will factor this part, and then we'll factor this part. Beginning with the first part, we can factor x cubed minus x squared to be x squared times x minus 1. The second part can be factored as negative 9 times x minus 1. Now notice that both parts feature x minus 1. As such, we can combine both parts as follows. At this point, notice that we can still factor x squared minus 9 even further. This can be factored to be x minus 3 times x plus 3. Now that we have completely factored the left-hand side, we can see that x must equal 3, negative 3, or 1. At this point, do we have sufficient information to evaluate the expression in the target question? Well, if x equals 3, then 5x squared plus 1 will equal 46. If x equals negative 3, then the expression evaluates to be 46 as well. If x equals 1, then the expression evaluates to be 6. Since the three values of x fail to yield just one answer to the target question, statement 1 must be not sufficient, which means the answer is B. To summarize, when tackling data sufficiency questions, always read both statements and begin with the easier statement. Doing so will help you to avoid common traps, gain insight into the question, build confidence, and guide you if you are forced to guess.